Good day, Dacians, and welcome to today's episode of our pre-calculus class. Before we start with our discussion for this day, I would like you to think first of a sport. So most of you have thought about basketball, volleyball, badminton, or soccer, and welcome to today's episode. All of those mentioned sports have something in common. Start with our discussion for this day, and that is, I would like you to think there is an object that is being hit by our and welcome to today's episode of our pre-calculus class. Before we start with our discussion for this day, I would like you to think first of, let's say we have a man holding a basketball. Now, to both of you have thoughts about basketball, volleyball, badminton, or soccer, and welcome to today's episode. All of those mentioned sports have something in common. Start with our discussion for this day, and that is, I would like you to think there is an object that is being hit by our and welcome to today's episode of our pre-calculus class. Before we start with our discussion for this day, I would like you to think first of, let's say we have a man throw the ball away so that it will reach the basket. So both of you have thoughts about basketball, badminton. So if the man just throws and welcome and the balls, all of those mentioned sports have something in common. Like this. Start with our discussion for this day. If we're going to think there is an object that is being hit by our and welcome to today's episode of our pre-calculus class. Before we start with our discussion for this day, I would like you to think first of, let's say we have a man throw the ball away so that it will reach the basket. So both of you have thoughts about basketball, badminton. So if the man just throws and welcome and the balls, all of those mentioned sports have something in common. Like start with our discussion for this day. If we're going to think there is an object that is being hit by our and welcome. Now, the goal of this volleyball player is to hit this ball and then take it to the other side of our net. So the path of the ball will be something like this. Okay? And something similar with those two paths, it is both curved. Okay? Curved is like going upwards and then going downwards. Okay? Now, this path that is being created by the ball in sports is what we call a parabola. Okay? So, for our today's discussion, we'll be dealing about parabolas. Okay? Now, parabolas are not only the downwards path, no? It can only be upwards, okay? It can also be seen in some pendulums, no? So if we draw a pendulum like this, okay, the movement of the weight of the pendulum can imply a parabola. So since its movement will be from this one going to this one, okay, it can be like that. It can be a parabola, okay. And also another example is a boomerang. We can see some paths of the boomerang, it's sidewards. Okay, if like this is a boomerang, the path is like that one. Okay, it can be a parabola. Okay, but not all the times it's a parabola. Okay, because sometimes it's arcs or portions of a circle. Okay, another example is the orbits of the comets. Okay, it's some of the orbits of our comets is it's elliptical, it's parabolic in shape. Okay, so meaning once they reach or once the comet nears the sun, it will change its path and then it will create a parabolic path. Okay, just like this. If this is the sun, okay, and this is the comet. Okay, let's say this is the comet. If this comet goes near to the sun, it will immediately change its path. It will bend, and then it will go around the sun. Okay, meaning this path that is being taken by a comet can be a parabola. Okay, now at this moment, we're going to analyze parabola more. Okay, or we are going to analyze it. We are going to define it mathematically. Okay, so what are parabolas? Okay, mathematically speaking, it is the set of all points such that the distance from a given point and a given line is the same. Okay, now let's illustrate it into a graph. Okay, now here is an example of a graph of a parabola. Okay, so here we have our fixed point. Okay, this fixed point is called the focus of the parabola. This term focus, we have already encountered it on our previous video from our ellipses. Okay, and this is one difference of ellipse and a parabola. No, the ellipse has two foci, while this parabola only has one focus. Okay, it has one fixed point. Okay, and that fixed point is inside this parabola. Okay, if we're going to get this distance from point F, our focus, to point P, this point P is on the parabola. Okay, and we're going to get the distance from the same point to our directrix. Okay, the directrix is our fixed line or our given line. It will not move. Okay, so the distances that we can get is the same. Okay, now let's see some distances or some examples of the distances for those two. Okay, now here at the left side of our screen, we have here the distance from point F to P. Okay, so point F to P. So it's 8.125, and it's the same as the distance from point P to line L. And that line L is this one, this red line. It's our directrix. Okay. Now, if we're going to drag this point P on our given parabola, okay, as we can see on our distances here, on our values here, okay, the values will be changing, but it is always the same no matter where this point P is. If it's here, it's 11.33, about 11.33, so both of them has the same value. Okay, and even if this point P is here near the middle, it would have the same value. Okay, now speaking at the middle point of our parabola, we have here point V at the exact middle of our focus and our directrix. Now this point V is this point V in our parabola is called the vertex of the parabola. Okay, sounds familiar, right? Okay, so this vertex, okay, would be our reference point from our parabola, since a parabola doesn't have any center. Okay, so another difference between an ellipse and a parabola is that a parabola is an open curve. Okay, um, unlike ellipses and also circles, those are closed curves. So meaning, since this parabola are open curves, this arrowhead may extend infinitely. Okay, so meaning we cannot really locate where the center is. So we'll be disregarding the center term. We're going to use the vertex instead of our center. Okay? Okay. Okay. Now let us analyze more about parabolas. Okay? Now, at this point, we're going to try to create equations of a parabola. Okay, now a parabola can either be vertical or a horizontal parabola. Okay, so let us illustrate the vertical and horizontal parabola. What does it look like? Okay, so let us have first a vertical parabola. A vertical parabola can either open upwards or downwards. Okay, so it can either be like this, it's upwards, or it can also be like this, it's downwards. Okay, if our parabola is horizontal, It can open at the right, and it can also be opened at the left side. So this is a parabola opened at the right and a parabola open at the left. Okay? Now, going back to our equations of our parabolas, okay, since we have differentiate a vertical and a horizontal parabola, now we can see here that our reference is now our vertex. It's not the center anymore. Okay, again, because there is no center in a parabola, so we simply use the vertex. Okay, so we have here a parabola with vertex at the origin, and if it's a vertical parabola, we have x squared equals 4cy as our equation, okay, or our standard form of the equation. Now, if it's horizontal and still have a vertex at the origin, we have y squared equals 4cy. 4cx rather. Y squared equals 4cx. Okay. Now, if it's vertical and its vertex is not at the origin, it's on the point hk somewhere on our Cartesian plane. It would be the quantity x minus h squared equals 4c times the quantity y minus k. So here we can see it here. Okay. Now, for the horizontal parabola with standard equation with vertex at hk, we have here y minus k squared equals 4c times the quantity x minus h. Okay. Now, one variable common in these four equations is the variable c. So what does the variable c means? Okay. The variable c is the measurement from our vertex to our focus. Okay, so again, C. May I erase this one first? Okay, C. Okay, it's the distance from our vertex to our focus. Now, aside from measuring the distance from the vertex and the focus, okay, we are going to consider the location of the vertex and the focus. Okay, where is the focus with respect to our vertex? Okay, why do we need to do that? Because it will change the value of C. Okay, now if the vertex, let's say we have the vertex here, or if the vertex is here and if the focus will be located above our vertex, or the focus is at the right of our vertex, okay, this will give us a positive value for C. Okay, now if our focus can be located below our vertex, okay, or the focus is at the left of our vertex, it will denote a negative value for C. Now, for you to easily remember this one, just remember the famous Cartesian plane by Rene Descartes. Okay, since we have here, okay, the Cartesian plane. Okay, so this part is the positive x-axis, this part is the negative x-axis. So if it's going to the right, it's positive. If it's going to the left, it's a negative. If it's going up, it's positive. If it's going down, negative. Okay? Okay. So with this, we are now ready to create equations of a parabola. We try with our first example. Okay, example number 1. Okay, so we are going to find the equation of the parabola in standard form with vertex at 2, 3 and focus 3 units below our vertex. So first, we're going to jot down our given information from problem number or example number 1. Okay, so we have the vertex at 2, 3. Okay, and focus 3 units below our vertex. Okay, so there are two things, actually 3 things that we need to know before we create the equation. Number 1 is our vertex. Number 2 is the value of C. And number 3 is the orientation of our parabola. Okay, so we have now here the vertex. Now let's try to solve first for the value of C. Okay, so C again is can be measured from the distance of the vertex and the focus. So since the focus is 3 units away from the vertex, C will be 3. Okay, but as we mentioned a while ago, C can take a positive or a negative value. Okay, now since the focus is 3 units below the vertex, it's below the vertex. So if you're going to illustrate it, it's like this one. Okay, the direction is downwards. So the value of the C will take a negative value. Okay, again, if the focus is below or at the left side of the vertex, the value of C will be negative, and so C will not be simply 3, but it's negative 3. Okay, so may I write it here? C is negative 3. Okay, next is to determine our orientation. Okay, so to determine our orientation, again, we consider the position of our focus and our vertex. Okay, now if the focus or the focus is below or above the vertex, which it means that it has a vertical movement. Okay, and if the direction is vertical, the parabola should also be vertical. Okay, now if it's mentioned that the focus is at the left or at the right, it has a horizontal translation or movement. So meaning our parabola is also will be horizontal in its orientation. So in this given problem, we have below, so we have the word below, so meaning the direction is downwards, it's vertical, so our parabola will be vertical also. Okay, it's a vertical parabola. Okay, now let's see our standard equation or the pattern of our equation from our table before. Okay, so we have this one. Okay, so since it's vertical and vertex at 2, 3, so we have to use this one. Okay, so this one. Okay, ayan. So vertical and centered at, rather vertex at H. Okay, so it would be the quantity x minus h squared equals 4c times y minus k. Okay, so the last thing to do is to substitute our values. We have here our vertex at 2, 3. So since the vertex will be our reference, not since it doesn't have any center, the format again is hk. So the x coordinate of our vertex is h, and the y coordinate of our vertex is k. So h will be equal to 2 and k will be equal to 3. Okay, substitute the values on our given standard equation. We'll be having x minus 2 squared equals 4 times c, which is a negative 3. So that would be 4 times a negative 3. Then y minus k, which is 3. Now simplify 4 times a negative 3. We'll be ending up with the equation x minus 2 squared, or the quantity x minus 2 squared equals negative 12 times the quantity y minus 3. Now this would be our equation in its standard form. Okay? Okay, so again, that's the quantity x minus 2 squared equals negative 12 times the quantity y minus 3. Okay, now let's have another example in creating equations of a parabola. Okay, now let's have this one. Okay, we need to find the equation of the parabola in standard form with vertex at negative 1, 4. And a directrix 5 units at the left of our vertex. Okay, so jot down again our given information. Okay, our vertex is at negative 1, 4, and our directrix, this time our given is directrix. Okay, the directrix is 5 units left of our vertex. Okay, now we have our vertex. Okay, now we solve for the value of C. Now, C will come from the vertex and the focus. Since we have a given directrix, we are going to locate the position of our focus using our directrix and our vertex. So now, let's say this is our vertex. At the left of it is our directrix. Okay, and its distance is 5 units. Okay, now, if we're going to look closely here on our graph, okay, so let us look again with this graph. Okay, we can notice that this our vertex is at the exact middle of the focus and our directrix. Okay, it can also be derived from the definition of the parabola a while ago. Okay, so since the directrix is at the left side of our vertex, the focus should lie on the other side of the vertex. Okay, again, since the directrix is at the left, at the right of the vertex should be our focus. Okay, and remember the distance from our the definition of our parabola. Okay, the distance from the vertex to focus, or from focus to any point on the parabola, and from that same point to the directrix will be the same. And since the vertex is on the parabola, the distance from this vertex and focus is also 5. Okay, it's the same. Okay, now if we're going to sketch the graphs, the graph will somehow look like this. So, okay, the opening of the graph or the parabola will be at the right. Okay, remember, if we're going to try to sketch this graph, the focus should always be inside the curved parabola. Okay, it should not intersect to our directrix. Okay, now since we have determined that its opening is at the right, okay, we can conclude that its orientation also is with respect to the direction right, the movement towards the right, and it's horizontal in nature. Okay, so it's a horizontal parabola. Okay, now this time, what will be the value of C? C would be equal to 5. Now, is it positive or negative? C will take a positive value at this example because the focus is at the right side of our vertex. The direction of the movement from vertex to focus is towards the right side. Okay, so C would be positive 5. So a horizontal ellipse with vertex at negative 1, 4, and a C value of 5. Now let's look to the table again for us to know what standard equation we shall use. Okay, so it's horizontal, so we have this column. Okay, and its vertex is not at the origin, so we're going to use this one. The quantity y minus k squared equals 4c times the quantity x minus h. Okay, so we're going to simply substitute our given, or the values of our given or informations to this equation. Okay, so our center is negative 1, 4, so negative 1 is h, we're going to substitute it here, and 4 is our k, so we're going to substitute it here. C is 5, substitute it at C. So we'll be having y minus 4 squared equals 4 times 5 times x minus negative 1. Okay, now simplify further, we'll be having the quantity y minus 4 squared equals 4 times 5, that is 20, times x minus negative 1. X minus negative 1 will be equal to x plus 1. And now this would be the equation of our ellipse given our problem or example number 2. Okay, now let's try to solve one more example for finding the equations of an ellipse. Okay, now let's try this one. We are going to find the equation of the we are going to solve for the equations of the parabola. Okay, at example number 3, we're going to find the equation of the parabola in standard form with focus at 0.7 and directrix at 14 units below our focus. So what we're going to do is to jot down our information first. Okay? So we have our focus at 0.7. We have also the directrix. It's 14 below our focus. Okay? So let's illustrate first this expression. The directrix is 14 units below the focus. So let's say this is our focus. 14 units below it is our directrix, our fixed line. Okay? And the distance from our focus here to our directrix is 14 units. Okay? Now, first we're going to locate where is our vertex. Our vertex is located at the exact middle of our focus and our directrix. Okay? Remember, the distance from the focus to vertex and vertex to our directrix is the same. We have seen it on our previous example. So what are we going to do is to divide our distance, which is 14, into 2. Okay, 14 divided by 2, that will make 7. So the distance from the focus to our vertex is 7. And also from the vertex to the directrix, it's also 7. Okay, now let's locate our center, our vertex rather. Okay, now it's given or it's known that our focus is at 0, 7. So we're going to translate this point 7 units downwards for us to reach our vertex. So moving downwards will only change the value of the y coordinates. Okay, since the movement is vertical, it is with respect to our y-axis. That's why we're only going to change the y values. If the case is the translation or the movement is horizontal, it's with respect to the x-axis. So we are going to change only the x coordinate. Okay, now since it's downwards, we're going to subtract 7 to our y coordinate. 7 minus 7. So our vertex will be located at 0, 0. It's at the origin. So we're going to take note of that. The vertex is at the origin. Okay, the vertex is at the origin. Okay, now afterwards we're going to look for the value of c. The value of c will come from the vertex to the focus. Okay, so the distance between the vertex and the focus is 7. Okay, and c will be equal to positive 7 since the focus is above our vertex. Okay, so c will be equal to positive 7. Okay, now we're ready to create our equation. Let me erase this first. Okay, we're going to look again to our table. Okay, so let's have our table. So we have here, we should find the general standard equation for a parabola with vertex at the origin. So it's either this one or this one. Okay. Now the question is, we haven't identified the orientation, right? So identify first its orientation. Remember, look at the keyword from our example problem. Okay. So we have here the word below. Okay. So the directrix is below the focus. Okay. And so therefore, okay, since from the value of c equals 7, we have concluded there that the focus is above our vertex. Okay, so those words below and above indicates that there is a vertical positioning. Okay, and so therefore we must have a vertical parabola. Okay, now let's see for the vertical parabola with vertex at the origin. So we have our standard equation. Our standard form of the equation is x squared equals 4cy. Okay? Now, substitute the value of c, which is 7. So we have x squared equals 4 times 7y. Simplify 4 times 7, that would be 28. So x squared is equal to 28y. And this would be our equation for our example number 3. Okay, this would be our equation of the parabola in our example number 3. It's x squared equals 28y. Okay? 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 Now, to summarize our discussion for today, okay, first, to create our equation of our parabola, we need to locate first the vertex and find the value of our variable c. Okay? Now, if the vertex cannot be located, we can locate it at the middle of our vertex and the directrix. Okay? Also, we can find the value of c by determining the distance between the vertex and the focus. Okay? And a note, if the focus is either above or at the right of the vertex, c is positive. And if the focus is below or at the left of the vertex, c will take a negative value. Okay? Now, for today's practice or exercise, I want you to get your book, our pre-calculus book, and turn it on page 40. We are going to answer there, exercise A, items number 16 to 30. Okay, this will be a practice for us to to apply our skills or apply what we have learned about creating equations of a parabola. Okay? So that would be all for our discussion for today. And see you on our next video discussion.
Good day, Daisians. I am Engineer Heidi Rose G. Mendoza, your instructor for the subject Introduction to Maritime Career. So for this episode, we are going to discuss about the different types of cargoes carried on board ships. Okay, so we all know that even today, shipping is considered as the best mode of transportation and transfer of goods because it is safer and more economically friendly for the shippers. Okay, so what are those cargoes that are carried on board ships? The first one is the container cargoes. So what are the example of container cargoes? Toys, televisions, DVDs, clothing, meat, and computers. Containers are the best way to transport these and many similar products. By efficiently loading the goods, they can be transported simultaneously in large quantities. And the goods are well protected against the elements by the container's metal walls. Okay, so some shippers prefer this type of or mode of transportation of their goods to be put inside a container because it is safer, because it is protected by the metal walls of the container box. Okay, so next cargo is the liquid bulk or the liquid cargoes. So what are those? All of us will have come across liquid bulk cargoes in everyday life in one form or another. From gasoline to fuel our cars, to fruit juices and cooking oil for consumption in the home. It's difficult to live the lives we live today without them. So those type of liquid cargoes are being transported via via tanker vessels. Okay, so these free-flowing liquid cargoes, which also include crude oil, liquefied natural gas, and chemicals, are not boxed, bagged, or hand-stowed. Instead, they are poured, binubuhos into, and sucked out of large tank spaces, known as the holds of a parcel tanker. Okay, so next type of cargo is the dry bulk. So if we have liquid bulk, we have also dry bulk. Examples of dry bulk. Okay, so from grains to coal and from sugar to cocoa. Dry bulk cargoes cover a range of product and raw materials that have two features in common. They are unpacked and are homogeneous. Other bulk cargoes include iron ore, alumina, fertilizers, scrap, sulfur, and cement, as well as a large number of agricultural products for the human and animal food industry, such as rice and corn. So technically, when we say dry bulk, it is usually in the form of grains, not packed. Okay? They are not packed or they are not put into sack or in any container like boxes. So, if we have dry bulk, of course, we also have break bulk. So, what is break bulk? In modern context, break bulk is meant to encompass cargo that is transported in bags, boxes, crates, drums, or barrels, or items of extreme length or size. To be considered break bulk, these goods must be loaded individually, not in intermodal containers nor in bulk as with liquids or grains. So, kanina nabanggit dun sa dry bulk that dry bulk is not something packed. So, kapag ka po nakapack na yung cargo, ang tawag na po natin doon ay break bulk. For example, this picture, for example, they are transporting rice in sacks. Okay, so since the cargo or the rice is packed into a sacks, these are already considered as break bulk cargo and not already a dry bulk. Okay. Next, gas cargo. The gas itself is normally propane or methane, known as LPG and LNG, respectively, and can be used in a variety of applications from environmentally friendly fuels and refrigerant to propellant in package aerosols and industrial chemical processes. Okay, so this type of cargoes are, or this type of gas cargo are carried by a vessel what we call as LPG and LNG carrier. So this is what it looks like. It looks like a tongkan. Next is refrigerated food cargo. So have you ever wondered, for example, when we go to the grocery, we see a product, for example, a meat, and then in the package, we see that it came from Australia. So have you ever wondered how it is being transported without being rotted? So the reason why it is not being rotted even though it came from the different country is that because it is transported via a refrigerated cargo, and these are transported via vessel what we called as reefer. So what are the examples of the cargoes that can be transported in a reefer vessel? So it includes fresh fruits and vegetables, fresh and frozen meats, poultry, seafood, dairy products, eggs, fresh juices, frozen concentrates, live plants, and flowers. So to preserve its goodness, it is transported via reefer vessels. Next type of cargo being carried on board ship is ro-ro cargo. So ro-ro refers to roll-on and roll-off cargo. So this name explains how the cargo is discharged and loaded. So this concerns cargo that can be driven, which is only done by specially trained drivers. Ro-ro is used for cars, buses, trucks, agricultural vehicles, and cranes. To transport as many of these vehicles in one go, enormous ro-ro vessels have been built. Okay, so when we say ro-ro cargo, it means or it also means wheeled cargo, yung may mga gulong that is driven by specially trained drivers. Next type of cargo is the livestock. Okay, so when we say livestock, it also means animals, live animals. Okay, so ships that are used for the purpose of transferring cattle across the seas are known as livestock carriers or cattle ships. So these animals, the animals that are used in such livestock carriers include sheep, goats, cows, and other forms of cattle. So just remember that when we say livestock, it is the transportation of live animals. Next is the timber cargo. Timber cargoes come in many forms and sizes and may consist of logs, cants, rugged end packages, or packages that are square or flush both ends. Okay, so technically these are the wood products. So the vessel that are used to transport this type of cargo is what we called as the log carrier, or sometimes we call this as the timber carrier. So that's all. So if we're going to have a recap, the different types of cargo that are being carried on board ships are container cargo, liquid cargo or liquid bulk, dry bulk, breakbulk, gas cargo, refrigerated food cargo, ro-ro cargo, livestock, and timber cargo. Okay, so thank you, and that's all for this episode. And I hope I was able to help you with the understanding of the different types of cargoes that are being transported in a vessel. So, thank you and see you on our next episode.